620_W23_QP_41. 2 Boron and aluminium are group 3 elements. 8 Boron has only 2 naturally occurring isotopes. Complete table 2.1 to show the numbers of protons, neutrons and electrons in an atom of M15P and 5E. M26N. B. The relative atomic mass of boron to 1 decimal place is 10.8. I. Determine the relative abundance of present in boron. Give your answer as a percentage. 20%. E. Use the relative atomic mass of boron to calculate the number of atoms in 0.540 grams of boron. Give your answer in standard form. 0620_W23_Ms_42. 1 Table 1.1 gives the electronic configurations of some atoms and ions, A to G. Answer the following questions about A to G. Each letter may be used once, more than once or not at all. State which of the atoms or ions, A to G, could be A. A noble gas atom. B. An atom of an element in group 6. F. C. An atom with an atomic number of 14. D. Atoms from the same group. And A and E. A halogen atom. G. F. An atom of an element which is a good conductor of electricity. C. A stable ion of a group 5 element. B. An atom that forms an ion with a 2 charge. F. 0620_W23_Ms_43. 2 Table 2.1 gives information about particles A, B, C, D, E and F. A. Give the letters of all the particles which are I atoms, A, B, F. E ions with a charge of 2. D. E cations. C. B. State the atomic number of A. 5. C. Determine the number of nucleons in D. 33. D. State the electronic configuration of D. 2. 8. E. State the group number of F. 5. F. State the period number of B. 2. 0620_S23_Ms_41. 2. 8. The symbols of the elements in period 2 of the periodic table are shown. Li BBCNOF NA. Use the symbols of the elements in period 2 to answer the questions that follow. Each symbol may be used once, more than once or not at all. Give the symbol of the element that I makes up approximately 78% of clean, dry air. E contains atoms with only 3 electrons in the outer shell. E contains atoms with only 9 protons. IV exists as graphite. V is an alkali metal. V only has an oxidation number of 0. 2AIN, 2AEB, 2AEF, 2AIVC, 2AV Li, 2AV Na. B. Boron, B, has 2 isotopes. I. State the meaning of the term isotopes. Different atoms of the same element with the same number of protons. M. 2 different numbers of neutrons. E. Table 2.1 shows the relative masses and the percentage abundances of the 2 isotopes of boron. Calculate the relative atomic mass of boron to 1 decimal place. 2 BEM 110x20 plus 11x80 equals 1080. M2 1080 divided by 100 smiley face 10.8. 0620_S23_Ms_42. 2 Fluorine, chlorine and bromine are in group 7 of the periodic table. 8. State the name given to group 7 elements. Halogens. B. Explain why group 7 elements have similar chemical properties. Same number of outer shell electrons. C. Complete table 2.1 to show the color and state at R, T, P, of some group 7 elements. D. Bromine has 2 naturally occurring isotopes. I. State the term given to the numbers 79 and 81 in these isotopes of bromine. 2. Di. Nucleon number, mass number. E. Complete table 2.2 to show the number of protons, neutrons and electrons in the atom and ion of bromine shown. E. Table 2.3 shows the relative abundances of the 2 naturally occurring isotopes of bromine. Calculate the relative atomic mass of bromine to 1 decimal place. 2 DEM 179x 55% plus 81x 45%. M2 and 7991 hundredths equals 79.9. E. Chlorine displaces bromine from aqueous potassium bromide but does not displace fluorine from aqueous sodium fluoride. I. Write the symbol equation for the reaction between chlorine and aqueous potassium bromide. E. State why chlorine does not displace fluorine from aqueous sodium fluoride. Chlorine less reactive than fluorine. F. Aqueous silver nitrate is a colorless solution containing I. Describe what is seen when aqueous silver nitrate is added to aqueous sodium chloride. White precipitate. E. Write the ionic equation for the reaction between aqueous silver nitrate and aqueous sodium chloride. Include state symbols. 0620_S23_Ms_43. 2. The symbols of the elements in period 3 of the periodic table are shown. Na MgAlCpScLAr. Use the symbols of the elements in period 3 to answer the questions that follow. Each symbol may be used once, more than once, or not at all. Give the symbol of the element that I is present in purified bauxite. E contains atoms with a full outer shell of electrons. E is used to kill microbes in water treatment. IV forms an amphoteric oxide. V forms an oxide which causes acid rain. V has an oxidation number of -1 when it forms a compound with hydrogen. 2AiAl, 2AeAr, 2AeCl, 2AiVal, 2AVS, 2AVCl. B. The relative atomic masses of elements can be calculated from the relative masses of isotopes and their percentage abundances. I. Identify the isotope to which all relative masses are compared. E. Table 2.1 shows the relative masses and the percentage abundances of the two isotopes in a sample of magnesium. Calculate the relative atomic mass of magnesium to 1 decimal place. M124x 85% plus 26x 15%. M2 in 2430 100 equals 24.3. C. An ion contains 10 electrons, 13 protons and 14 neutrons. I. State the nucleon number of the ion. 27. E. Identify the element that forms this ion. Aluminium, Al. 0620_M23_Ms_42. 2. Lithium, sodium and potassium are group 1 elements. 8. Name the type of bonding in these elements. Metallic. B. Sodium reacts with cold water to form hydrogen gas and a solution of a strong alkali. I. State the test for hydrogen gas. Test. Positive result. Lighted splint and squeaky pop. E. Suggest the pH of a solution of a strong alkali. 14. E. Name a substance which can be used to confirm the pH of a solution of a strong alkali. Universal indicator. IV. Write the symbol equation for the reaction between sodium and cold water. Include state symbols. C. Lithium has 2 naturally occurring types of atoms. I. State the name given to atoms of the same element with different nucleon numbers. Isotopes. E. Complete table 2.1 to show the number of protons, neutrons and electrons in the atom and ion of lithium shown. E. Table 2.2 shows the relative abundance of the 2 naturally occurring atoms of lithium. Calculate the relative atomic mass of lithium to 1 decimal place. M1 6x10 plus 7x90 equals 690. M2 and 690 100 equals 6.9. D. Potassium oxide is an ionic compound. Complete Fig. 2.1 to show the electronic configurations of the ions in potassium oxide. Show the charges on the ions. M1 8 dots in third shell of both K. M2 6 crosses and 2 dots in second shell of O. M3 feet plus, charge on each K on correct answer line and 2. Charge on O ion on correct answer line. 0620_W22_Ms_41. 1. The names of the elements of period 2 of the periodic table are shown. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Answer the following questions about these elements. Each element may be used once, more than once or not at all. Identify the element which A. is a product of photosynthesis. B. has an oxide found in clean, dry air. C. forms a basic oxide with the formula X2O. D. is a main component of fertilizers used to improve crop growth. E. has the highest rate of diffusion at room temperature. F. produces a red flame in a flame test. G. has only 5 electrons in each of its atoms. H. has an oxide responsible for acid rain. Total 8. A. oxygen. B. carbon. C. lithium. D. nitrogen. E. neon. F. lithium. G. boron. H. nitrogen. 2. Potassium is a group 1 element. 8. Name and describe the bonding in potassium. Name. Description. M1 metallic. M2 lattice of potassium ions. M3 sea of electrons. M4 attraction between potassium ions and electrons. B. Potassium combines with sulfur to form an ionic compound, potassium sulfide, K2S. I. Give 2 physical properties of ionic compounds. Any 2, 1 from each bullet point. Physical constants. High boiling point, melting point. Conductivity. Conduct electricity when aqueous, conduct electricity when molten. Solubility. Soluble in water. E. Complete the dot and cross diagram to show the electron arrangement and charges of the ions in potassium sulfide. M1 8 dots in third shell of both K. M2 6 crosses and 2 dots in third shell of S. M3 feet plus, charge on each K on correct answer line and 2, charge on S ion on correct answer line. C. When potassium is added to water, it reacts vigorously and a colored flame is seen. The equation for the reaction is shown. I. State the color of the flame seen. E. The solution formed is potassium hydroxide, a strong alkali. State the formula of the ion responsible for alkalinity in a solution. E. State the color of litmus in a strong alkali. IV. Calculate the volume, in cm3, of hydrogen gas formed when 2.34 grams of potassium is added to excess water at room temperature and pressure. Use the following steps. Filled circle. Calculate the number of moles of potassium added. Equals. Mole. Filled circle. Determine the number of moles of hydrogen gas formed. Equals. Mole. Filled circle. Calculate the volume of hydrogen gas formed. Volume equals. cm3. Ci, lilac. CEO. Ce, blue. Civ. M1 mole of K equals 2. 34/39 equals 0.0600. M2 moles of H2 equals 0.062 equals 0.0300. M3 volume of H2 equals 0.0324,000 equals 720 cc. D. Aqueous potassium hydroxide reacts with a dilute acid to produce aqueous potassium chloride. KCl-AQ, which is a salt. I. Name the dilute acid used. E. State the type of reaction taking place. E. Name the experimental technique used when salts are made by reacting a dilute acid with an aqueous alkali. D. I. Hydrochloric acid. D. E. Neutralization. D. E. Titration. E. When aqueous silver nitrate is added to aqueous potassium chloride, a precipitate is formed. I. State the color of the precipitate formed. E. Name the precipitate formed. E. Write the ionic equation for the reaction. Include state symbols. 3. E. I. White. E. E. Silver chloride. 0620-S22_Ms_41. 2. A. Atoms are made of protons, neutrons and electrons. Atoms of the same element are known as isotopes. Complete the table to show the numbers of electrons, neutrons and protons in these isotopes of magnesium. E. Explain why magnesium ions have a charge of 2+. They have 2 more protons than electrons or. They have 2 fewer electrons than protons or. They have 12 protons and 10 electrons. B. Mg2+ ions have the electronic structure 2, 8. Give the formula of the following particles which have the same electronic structure as Mg2+. Ions. Filled circle a cation, positive ion. Dot. Filled circle an anion, negative ion. Dot. Filled circle an atom. 0620-S22_Ms_42. 1. The symbols of the elements of period 3 of the periodic table are shown. Answer the following questions about these elements. Each symbol may be used once, more than once or not at all. Write the symbol of the element which A. Forms a stable ion with a 2+ charge. B. Is the least reactive in the period. C. Is used in water treatment. D. Forms an oxide which is the main impurity in iron ore. E. Is an important component of fertilizers. F. Is stored under oil. G. Is used in food containers. H. Is found in the ore-zinc blend. 1 A Mg1. 1 B Ar1. 1 C Cl1. 1 D C1. 1 E P1. 1 F Na1. 1 G Al1. 1 H S. 3 transition elements are found in the middle block of the periodic table. A. Chromium has several isotopes. Manganese has only 1 isotope. I. State what is meant by the term isotopes. I. Atoms of the same element, with different number of neutrons. E. State the nucleon number of manganese. 55. 24 protons, 28 neutrons, 21 electrons. B. One chemical property of transition elements is that they form colored compounds. I. Give the colors of the following hydrated salts. Filled circle hydrated copper 2 sulfate. Filled circle hydrated cobalt 2 chloride. I. Blue, pink. E. State 2 other chemical properties of transition elements. E. Act as catalysts. Variable oxidation state. C. Transition elements in group 1 elements are metals. They share many physical properties including the ability to filled circle conduct electricity, filled circle be hammered into shape. I. Explain why transition elements and group 1 elements conduct electricity. Mobile electrons. E. State the property that describes a material which can be hammered into shape. Malleability, malleable. D. Transition elements and group 1 elements differ in other physical properties. Transition elements are harder and stronger than group 1 elements. Describe 2 other ways in which the physical properties of transition elements differ from group 1 elements. Higher density. Higher melting points. 4. Fluorine and chlorine are halogens. 8. Suggest the appearance of fluorine. Pale yellow in gas 1. B. Fluorine reacts with sulfur to form a compound which has 25.2% sulfur by mass and a relative molecular mass of 254. Determine the molecular formula of this compound. C. Nitrogen trichloride, NCl3, is a covalent compound. Complete the dot and cross diagram to show the electron arrangement in a molecule of NCl3. Show outer electrons only. N with 1 dot cross bonding pair with each Cl. 2 non-bonding dots for N. 6 non-bonding crosses for Cl. D. Lithium chloride, LiCl, is an ionic compound. Complete the dot and cross diagram to show the electron arrangement and charges of the ions in lithium chloride. 2 crosses in first shell of Li. 7 dots and 1 cross in third shell of Cl. Plus, charge on Li on correct answer line and charge on Cl ion on correct answer line. 0620_W21_Ms_42. 5. Iron is a transition element. Potassium is a group 1 element. A. Iron and potassium have the same type of bonding. Name and describe the type of bonding in these 2 elements. Name. Description. Metallic. Lattice of positive ions. Sea of delocalized mobile electrons. Attraction between positive ions and electrons. B. Transition elements and group 1 elements have some similar physical properties. They can both filled circle be hammered into a shape. Filled circle conduct electricity. Filled circle be stretched into wires. I. Name the term used to describe the ability of elements to be hammered into a shape. Malleability, malleable 1. E. Describe what happens to the particles in iron when it is hammered into a shape. Particles slide over each other. 1. E. Suggest why copper, rather than other transition elements, is used for wires which conduct electricity. Unreactive 1. C. Transition elements are harder and stronger than group 1 elements. Describe how 2 other physical properties of transition elements are different from those of group 1 elements. Higher density. Higher melting points. D. Chemical properties of some group 1 elements are shown in the table. I. Add to the table. Filled circle the flame test colors for sodium and potassium. Filled circle the predicted reactions of rubidium with water and with oxygen. I. Na. Yellow. K. Lilac. Colorless solution. Clear idea of increased reactivity in both reactions. E. Name the gas produced when group 1 elements react with water. E. Name the solution formed when potassium reacts with water. IV. Predict the pH of the colorless solution formed when potassium reacts with water. V. Write the chemical equation for the reaction of sodium with oxygen. 2. 5De hydrogen 1. 5De potassium hydroxide 1. 5D IV any number in the range 7 less than pH less than slanted equal 14. E. Iron is a typical transition element. It is the catalyst used in the Haber process. I. Write the equation for the reaction that occurs in the Haber process. E. State the temperature and pressure used in the Haber process. Include units. Temperature. Pressure. E. 450 degrees Celsius. 200 atmospheres. 0620_S21_Ms_42. 1. The symbols of the elements of period 3 of the periodic table are shown. Na MgAlCpScLAr. Answer the following questions about these elements. Each element may be used once, more than once or not at all. Write the symbol of an element which A. Is malleable, B. Has only 2 electrons in its outermost shell, C. Forms an oxide which leads to acid rain, D. Forms an ion with a 2 charge, E. Is extracted from an ore called bauxite, F. Does not form an oxide, G. Forms an oxide with a macromolecular structure, H. Forms an amphoteric oxide, I. Exists as diatomic molecules, J. Forms a binary compound with hydrogen that is a strong acid. 1. A. Na or Mg or Al 1. 1. B. Mg. 1. C. S. 1. D. S. 1. E. Al. 1. F. Ar. 1. G. C. 1. H. Al. 1. I. Cl. 1. J. Cl. 2. Silver has an atomic number of 47. I. State the name given to atoms of the same element with different nucleon numbers. Isotopes. E. Complete the table to show the number of protons, neutrons and electrons in each atom. And ion of silver shown. E. Complete this definition of relative atomic mass. Relative atomic mass is the mass of naturally occurring atoms of an element on a scale where the atom has a mass of exactly units. IV. A sample of silver has a relative atomic mass of 108.0. 50%. B. Silver nitrate is a salt of silver made by reacting silver oxide with an acid. Write the formula of the acid which reacts with silver oxide to form silver nitrate. I. Describe what is seen when aqueous silver nitrate is added to aqueous sodium iodide. NiAQ. Yellow precipitate. E. Write the ionic equation for the reaction between aqueous silver nitrate and aqueous sodium iodide. Include state symbols. D. In the positive test for aqueous nitrate ions, aqueous sodium hydroxide and one other substance are warmed with the nitrate ions. Name this other substance and the gas formed. Name of substance. Name of gas. Aluminium. Ammonia. E. When silver nitrate is exposed to sunlight, silver is formed. Name the type of reaction which needs light to make it happen. Photochemical 1. F. Members of one homologous series only react with chlorine in the presence of sunlight. I. Name a member of this homologous series. E. Name two products that form when the compound in I reacts with chlorine. 1, 2. I. Any named alkane 1. E. Name of organic product derived from 2Fi. Hydrogen chloride HCl. 0620_W20_Ms_42. 3. Group 1 metals are very reactive. Transition elements are also metals but are less reactive than Group 1 metals. 8. State two physical properties of Group 1 metals which are similar to those of transition metals. 1, 2. Any two from shiny, lustrous, conduct electricity, conduct heat. B. Describe two ways in which the physical properties of Group 1 metals are different from those of transition metals. 1, 2. Low density. Low melting points. C. When Group 1 metals are added to water they fizz and an alkaline solution forms. I. Name the gas given off. E. Identify the ion present in the solution which makes the solution alkaline. E. Write the chemical equation for the reaction between sodium and water. C. I. Hydrogen. D. When the transition element iron is added to water the iron rusts. When an iron object is coated with a layer of zinc, rusting is prevented. I. Name this process of coating iron objects with a layer of zinc. E. Explain how completely coating an iron object with a layer of zinc prevents rusting. E. Rusting of iron ships can be prevented by attaching zinc blocks to the hull of the ship. Explain how this prevents rusting. D. I. Galvanizing 1. D. E. Prevents water and oxygen reaching iron 1. D. E. Zinc more reactive than iron. Zinc corrodes, oxidizes, reacts in preference to iron. 0620_W20_Ms_43. 2. The table gives information about 5 particles, A, B, C, D and E. 8. State the atomic number of A. B. State the nucleon number of B. C. Write the electronic structure of C. D. Give the letters of all the particles which are I. Atoms. E. Positive ions. E. Negative ions. IV. Isotopes of each other. 2. A. 11.1. 2. B. 38.1. 2. C. 2. 8. 8.1. 2. D. I. B. C and E1. 2. D. E. A1. 2. D. E. D1. 2. D. I. V. B and C. 5. Group 1 elements, Group 7 elements and transition elements are found in different parts of the periodic table. 8. Describe the trend in the reactivity of Group 1 elements. Become more reactive down the group Aura 1. B. When potassium is added to water a chemical reaction occurs. I. State 2 observations that can be made when potassium is added to water. 2. E. Write a chemical equation for the reaction of potassium with water. I. 1 mark each for any 2 of floats, dissolves, disappears, melts, moves, bubbles, fizzes, effervesces. Lilac flame. C. Excess aqueous potassium iodide is added to chlorine. I. Write a chemical equation for the reaction that occurs when aqueous potassium iodide is added to chlorine. 2. E. State the final color of the reaction mixture. E. Brown, black 1. D. Sodium is extracted from sodium chloride by electrolysis. I. State the meaning of the term electrolysis. 2. E. State what must be done to sodium chloride before it can be electrolyzed to produce Sodium. E. Write an ionic half equation for the change that occurs at the cathode during this electrolysis. 5d. Breakdown by the passage of electricity of an ionic compound in molten or aqueous state. 5d. Heat until it melts, heat to or above melting point. Use this information to give two properties of chromium which are different from properties of group 1 elements such as sodium. 1, 2. 1 mark for each of any two from. Chromium has high melting point aura. Chromium forms colored ions, colored compounds aura. Chromium has variable valency, variable oxidation state, variable oxidation number aura. Catalytic behavior aura. Aura allow group 1 or sodium if stated. No color or white or colorless ions or compounds. Fixed valency plus 1 charge only or 1 oxidation state forms 1 chloride. Low melting point. Doesn't behave as a catalyst. Use this information to give two properties of chromium which are similar to properties of group 1 elements such as sodium. 1, 2. 1 mark for each of any two from. Chromium, sodium conducts electricity. Chromium, sodium compounds are soluble in water. Chromium, sodium form. Hydrated salts form hydrated compounds. 0620_S20_Ms_41. 1. This question is about elements X, Y and Z. Name the different types of particles found in the nucleus of this atom of X. What is the term for the total number of particles in the nucleus of an atom? What is the total number of particles in the nucleus of an atom of IV? What is the electronic structure of the ion? V. Suggest the formula of the compound formed between aluminium and X. 1a. Protons. Neutrons. 1a. Nucleon number. 1a. 34. 1a. IV 2, 8, 8. B. What term is used to describe atoms of the same element with different numbers of particles in the nucleus? Identify the atom against which the relative masses of all other atoms are compared. 1b. Isotopes. 1b. A mole 1. 1b. IV Avogadro constant 1. C. Part of the definition of relative atomic mass is the average mass of naturally occurring atoms of an element. Some relative atomic masses are not whole numbers. Filled circle. Calculate the relative atomic mass of element Y to 1 decimal place. Filled circle. Identify element Y. M1 3 times 69 plus 2 times 71. M2 equals 349 fifths equals 69.8. M3Y equals gallium. D. Element Z is in period 3 and group 5. Identify element Z. Explain in terms of electron transfer why Z behaves chemically as a non-metal. 1d. Phosphorus P1. 1d. Gains electrons. 3 electrons when forming ion. 0620_W19_Ms_42. 1. The periodic table is very useful to chemists. Refer only to elements with atomic numbers 1 to 36 in the periodic table provided when answering. Question 1. Use information from the periodic table provided to identify one element which has atoms with exactly 9 protons. Has atoms with 0 neutrons. Has atoms with exactly 23 electrons. IV has atoms with an electronic structure of 2, 8, 6. V forms ions with a charge of 3 containing 18 electrons. V forms ions with a charge of 2 plus containing 10 electrons. V has a relative atomic mass that shows it has at least 2 isotopes. 1a fluorine F1. 1a hydrogen H1. 1a vanadium V1. 1a IV sulfur S1. 1a V phosphorus P1. 1a V magnesium per megagram 1. 1a V chlorine Cl1. B. State which metal in the first 36 elements. I is the group 1 element which reacts most vigorously with water. E. Reacts with air to form lime. 1b. Potassium K1. 1b. Calcium Ca1. C. 1 element in the first 36 elements is used as the fuel in a fuel cell. Name this element. E. Write the overall chemical equation for the reaction which occurs when the element in Ci reacts in a fuel cell. 1 Ci Hydrogen H. 0620_W19_Ms_43. 1a atoms are made of smaller particles called electrons, neutrons and protons. Complete the table. B. The table gives information about atoms and ions A, B and C. Complete the table.